Hello guys, in last class we did the series and parallel combinations of register, right? So if this is the series combination of register, this was parallel combination of register, right? So moving on to next topic, how cells are connected in series and parallel. We have already discussed about cells, that cells provide EMF, right? But before I take you to the series and parallel combination of cells, let me give you a circuit diagram and explain how EMF is different from the potential difference. See, this is a very simple diagram, very simple one. This is a cell connected to this resistor, right? Let us say this is R ohms, this is EMF E. Now if this EMF is of 3 volts, this resistance will not be getting 3 volts, it will be getting either 2.8 or 2.9 volt. So where is that 0.1 or 0.2 volts going? The 0.1 and 0.2 volt going is actually getting consumed by the internal resistance of this cell. So to eliminate this thing and to make a relation between potential difference and EMF, right now there must be some current I which is flowing through this resistor, right? So the voltage which this resistor is getting is, according to Ohm's law, V equals to whatever current is flowing through the resistor into the value of resistor. So this is the potential difference across this resistor or potential drop across this resistor, right? So V equals to IR. I can redraw the same circuit like this. I am taking the internal resistance in series with the cell. So basically what I have done from here, I have just removed the internal resistance and I have showed it somewhere else in the circuit, right? This is still V, this is R. Now consider this. Let I be the value of current, same which is flowing in this circuit. So the total voltage, what is the total voltage which is provided by this circuit is E, will be equal to total current into total resistance. What is total current? I. What is total resistance? This R and this R is right now in series. So E is equal to IR plus I small r. This E is equal to, this is V, right? The potential drop across cell, plus I into R. This gives me a statement that I into small r is equal to E minus V, or small resistance, that is internal resistance of this cell, would be E minus V upon I, right? This is simple. Now following the same order, if I do this diagram, consider this. I have two cells in series, both have the EMF E and internal resistance R. So what will be the total EMF which is provided by these two cells altogether? If this is 3 volt, this is 3 volt, they are together providing an EMF of 6 volts, alright. So right now here this will be twice of E. So what if there are n cells which are in series combination? I'll just explain you. What we guys have already discussed about the series and parallel combination of resistance, and we have seen that in series combination what physical factor remains constant? In series combination current remains constant, and in parallel combination, yes, the voltage remains constant, right? So I'll draw two circuits simultaneously. I have this cell and I have so many of these cells, let us say n number of cells, okay? And I have connected them all in series across this external resistor R. Each cell has this rating E comma R, that means EMF is E and internal resistance is R. The whole combination is connected to an external resistance R. This will be the flow of current, the direction of flow of current, right? Look another circuit. I have this, a cell of rating E comma R, and I have another cell I have another cell, and similarly I have so many cells. That means I have n cells right now, each connected to this and externally connected to the external resistance R. I have to find out the value of current in both the cases. Alright. What and how do we find the current? We know a universal formula of Ohm's law, which is E equals to IR. Right. First, let's sort it out. This one. I had just explained you, if two cells are connected, that means the EMF will be, net EMF will be twice of E. Three are connected, thrice of E. There are n cells in series right now. N cells. So what will be the net EMF? N times E. Alright. Now, just relate two things and you'll get the answer. Total voltage provided by the cells, the combination of cell or the circuit, is N times E. What is the total current flowing in the circuit? I. What is the total resistance of the circuit? This R and internal resistance of each cell are connected in series. Okay, consider this diagram like this. Small r, small r, small r, dash, 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 n times small r, then capital R. So what is the net resistance of this circuit? All these small resistance and the capital resistance are connected in series because that is the rule of series. They are all in the single line. Even if they are making a loop, but they are still in a straight line, single line, that makes them in series. And in series the formula is, we just need to add each and every resistor. So here the total resistance of the circuit is R plus what? N times small r. So this is the total resistance. So what would be the final answer? Total voltage provided is total current into total resistance. So the formula for current would straight away would be NE over R plus N times R. Right? That is simple. What will I do in this case? I have the rating E comma R. Each cell has this rating E comma R. This is external resistance R, and the current which is flowing again is I. And I want to figure out what is the total current, like we did in this circuit. What is the total current here? Go with the same method, you will get the answer. Find out the total voltage, find out the total resistance, find out the total current, you will get the answer. You just have to relate them. First of all, what is the total voltage? In parallel, voltage remains same. So even if n times E cells are connected in parallel, the net voltage would be still E. So this is the total voltage applied in the circuit. Now, what is the total current flowing? I, which we just mentioned. What is the total resistance of the circuit? All these resistors, the small internal resistors of the cell, which is small r, are like this, right? So if I have three resistors, 3 small r, how would I add them? They are in parallel. That means 1 upon r parallel would be 1 upon r plus 1 upon r plus 1 upon r. That means 3 upon r. That means r parallel would be equal to r upon 3. A basic definition or basic way of doing or finding out resistors in parallel is this. Just divide the number of resistors connected in parallel only if they are same, divided by what value? Take resistors, or they take the value of one resistor and divide it by the number of resistors which are connected in parallel. But you do this method only when they are equal in values. So right now there were 3, so my answer was r upon 3. So if I have n resistors parallel, here I have n resistors parallel, so what would be the parallel net resistance? R upon n. But this R upon n is connected in series with this resistor capital R. So total resistance is R, which is in series with R upon n. So the answer is this. So what is the value of current? Net voltage upon R plus R upon n. This is how we take currents and voltages in series and parallel.